Who's ready to sketch a slope field? I knew you were excited. These are really tedious, but they're easy. It's extremely rare that the AP test would ask you to sketch a slope field. You're far more likely to have to match a slope field to the differential equation. But if you can draw your own slope field, then matching becomes a piece of cake. So let's practice sketching our own, and then the rest of the homework should be nice and easy. What I do is I pick a point on the graph. Let's say I pick this point, and I just have to plug it into, I plug in the x-coordinate, I plug in the y-coordinate, and then this tells me the slope. So if I pick the origin here, and I type in, or I plug in 0, 0, so I have dy dx is equal to 0 minus 0, that gives me a slope of 0. I know that something with a slope of 0 is just a straight line, or just a horizontal line, and so I sketch a little dash right there. It's easy when it has a slope of 0. It's easy when it has a slope of 1, or when it has a slope of -1. It gets a little trickier when you have slopes of 2, 3, and higher. At that point, you're just kind of winging it. So if I know that, a 45-degree angle is my slope of 1, then a slope of 2 might just be a little steeper. A slope of 3 might be a little steeper. But then, how do I draw 4 because that was almost vertical? I don't know what to tell you. You're just kind of winging it. But again, if you can get close on your sketch, then you'll be in really good shape to match the slope field to the differential equation. Let's keep going. Let's choose the point 1, 1. If I plug that into my differential equation, I have 1 minus 1, which is 0. So I draw my segment with a flat horizontal line. And I can see that's going to be true at 2, 2, and at 3, 3, and here, and here, and here. When you can find a pattern, run with it. Let's pick another point. Let's pick the coordinate point 0, 1. I do 1 minus 0, and that gives me a slope of 1. So right here, I'm going to draw my line with a 45-degree angle, best I can. This will also be true at this point, right? 2 minus 1 is 1, 3 minus 2 is 1. So I can follow that pattern. Let's look at a point right here. If I have, let's see, that would be an x-coordinate of -2 minus a y-coordinate of -3. That gives me a slope of -1. Right? That will be true here, and here, and here, and here, and here. Nice little patterns. These are lovely. Let's choose this point. Here I've got x value of -3, y value of -2, so y minus -1 for the y value, minus -3 for the x. That gives me a slope of +2. Right? So when I go to sketch this, I'm just going to try something that's steeper than the -1 line that I just drew. It's going to be true here, and here, and here, and here. Nobody's going to go dig out their protractor and see, did you draw a slope? Did you draw a line with a slope of 2? No, it's going to be fine if you're just making an attempt. Look at this point. If I do 0 minus -3, that's a slope of 3. So what I'm just going to do is I'm just going to try to draw something that was steeper than the last slope. And it's a mediocre job. Those should have all been the same. And this should get steeper. Oh, and this should get even steeper. And now I'm practically drawing vertical lines, but we're just going to go with it. Right? And I would do this for all the points down here. I skipped ahead and I tried to sketch the whole thing there. Once again, I'm not looking for a great work of art, but I can see some nice features in this graph that would certainly help me, from a list of choices, match the differential equation to its slope field. That was supposed to be an arrow. Ooh, I'm gonna stop now. That's just getting awful.